Today on Inevitable, our guest is Steve Oldham, CEO of Captura. Captura has developed a direct ocean capture technology, or DOC, that removes CO2 from seawater, which then causes the ocean to naturally pull more CO2 out of the atmosphere to rebalance. The ocean contains CO2 at concentrations about 150 times higher than air, and Steve claims that Captura's approach requires no chemical inputs, produces no waste, and can run on off-peak renewable energy, potentially solving carbon removal's biggest scalability challenges. I wanted to have Steve on the show to learn about direct ocean capture, a technology I knew very little about before this conversation, but also because Steve has an incredibly unique background in carbon removal. Prior to Captura, he was CEO of Carbon Engineering, which he scaled from a small team to become the world's largest direct air capture operation. Steve established the foundational partnerships with Occidental that ultimately led to Carbon Engineering's $1.6 billion acquisition by Oxy in 2023, though he had moved on to start Captura before that exit was completed. Captura has raised around $47 million to date from strategic investors, including Equinor, Maersk, Aramco, and others. Let's dive in. From MCJ, I'm Cody Sims, and this is Inevitable. Climate change is inevitable. It's already here. But so are the solutions shaping our future. Join us every week to learn from experts and entrepreneurs about the transition of energy and industry. Steve, welcome to the show.
Well, thank you very much. Pleasure to be here.
Well, you have maybe the most robust background in carbon removal of anyone on the planet at this point. So there is so much to talk about. I think what I'd like to start, not that it's a rote thing to do, but just have you trace your background a little bit for us to set the tone of the conversation.
Sure, I'm happy to do that. First thing I always say to people is I'm completely unqualified for the job that I have. My background was in maths at school, university in England. And then I joined a space company in Canada and was involved in space robotics, in satellites, in brain surgery by robots, a whole bunch of interesting things. And then out of the blue, I was asked by a board member at Carbon Engineering if I would consider joining that company. That was back in 2017. So I joined Carbon Engineering. I think we had maybe 15 people at the time. I remember the facility was a pretty basic one. We had one toilet that ran continuously, never stopped, and a very old building that we were in. So I was at Carbon Engineering for just over 4 years, I think, and then moved to Captura, where I've been CEO almost since the company's foundation. I joined about, I think it was 4 months after the company was founded.
And we're going to spend a little bit of time on this, but maybe for folks who haven't connected the dots, you left before Carbon Engineering had its significant outcome, but maybe describe a little bit about that outcome that it did have and what has become of Carbon Engineering today.
So in my time at Carbon Engineering, we grew to 150 people, built our fully operating pilot plant in Squamish, British Columbia.
This is for direct air capture.
Yes. And we entered into a licensing agreement with Occidental in the United States for building our first plants. I've always had a view that with the size of the carbon removal industry, or the need of the carbon removal industry, I should say, partnering is an essential element of getting to scale. And Oxy were very forward-leaning. So we joined with them. We designed what is by far the largest direct air capture plant in the world, Stratos, which I'm excited to see should be operational this year.
I just saw some pictures of it on social media the other day. It's pretty incredible.
What I enjoy is it looks a lot like the artist's impressions that we did at Carbon Engineering about 3 years ago. So it's always nice to see. And Occidental got more and more interested in the business, and having negotiated the licensing deal with them and the start of the Stratos plant and all those things, they actually moved forward and decided to acquire the company at a valuation of $1.6 billion in 2023, I think it was, which is by far the biggest exit so far in the carbon removal space. Nothing but positive things to say about Carbon Engineering and Oxy. That partnership continues very strongly. I still know a lot of the people there in Squamish at Carbon Engineering and wish them all the best.
Little Canadian company. It's pretty impressive.
Yeah, and that little Canadian company mindset was part of the reason why we were so keen to partner with, I always referred to Oxy as our big brother, going to need a big brother when you're trying to do something difficult and ambitious. And Oxy were a terrific, and still are a terrific big brother for carbon engineering.
Well, we're going to come back to that because I do want to paint some comparisons between DAC, direct air capture, and DOC, direct ocean capture, which is what you're doing at Captura. So in order to do that, maybe let's have you dive into Captura and describe what the company is, what the technology is, and we'll have a little bit of back and forth on this as I learn, because I haven't done much in the way of understanding this space. So I'm certainly learning right alongside anyone who's listening.
Okay, so what's direct ocean capture? So let me start by saying why carbon removal is hard. CO2 in the atmosphere is 420 parts per million. So if you want to extract CO2 out of the atmosphere in the massive quantities that the climate needs, you have to move an awful lot of air. You have to absorb your CO2 into something. You have to regenerate that absorbent. All of that is hard. You'll often get critics say, what about the thermodynamic limit of energy use for extracting 400 parts per million? So Captura does this completely differently. What we do is we let the ocean do the hard work. We let the ocean remove CO2 from the atmosphere, and we take CO2 out of the ocean instead. So why does all of that work? So firstly, the ocean and the atmosphere are in a state of permanent equilibrium with respect to CO2 content.
I was reading something in prep for this interview about Henry's Law. Is that what we're about to dive into?
We're going to do Henry's Law.
All right, let's do it.
Which some people might have done at school many years ago. Henry's Law basically says that, yes, there has to be an equilibrium between the ocean and the atmosphere with respect to a gas. So every time we as a society put CO2 into the air, the ocean absorbs about 30%. And you'll have heard of ocean acidification, ocean warming, blanching of the coral reefs. These are impacts of this. I like to think of Henry's Law very simply. I'm a simple guy. Take a can of soda. The people who make the soda put excess CO2 into that soda can to make it fizzy. You open the can, pour it into a glass, put it on the table. As you watch, bubbles come up and the drink goes flat. That's Henry's Law.
So it's the equilibrium of the CO2 embedded in the soda making its way into the atmosphere.
Correct. There's too much, so the atmosphere pulls it out. But that same effect works the other way around too. If you take CO2 out of the liquid, the atmosphere has to put it back. So that's what we do at Captura. We take the CO2 out of the ocean water where it is 150 times more present than in the air. And then the ocean does the hard work of taking it out of the atmosphere. That way we are functionally equivalent to direct air capture. We produce a stream of CO2. It's measurable. But the ocean is doing the job of touching the air at massive scale, 70% of the surface of the planet.
As I was trying to understand this before this conversation with you, one of the things that jumped to my mind is, well, comparing it to DAC or direct air capture, you just said the opposite is true. So with DAC, is there some consideration where if we do remove CO2 from the atmosphere, it just sucks that CO2 out of the ocean back into the atmosphere? Or is that not the case because we're already so overburdened today from an atmospheric CO2 perspective?
So what you say is theoretically correct. And if overnight we stopped emitting CO2 and then we started to take CO2 out of the atmosphere, what you say is absolutely correct. You would end up with an outgassing from the ocean. The reality, of course, today is that we continue to emit at large scale. So even as DAC is reducing CO2, other people are putting more and more up there. So you don't see that outgassing effect yet. But in a net zero world in the future, what you say is true.
Should we get there, I guess that's a good thing.
That's a good problem, I think.
Okay, so DOC, direct ocean capture, is the process of pulling ocean water into a facility, extracting the CO2 from that water, allowing the water to be safely returned back to the ocean in a way that then it sucks CO2 from the atmosphere back into the ocean also. Is that correct? Am I understanding the high level?
Yeah, that's a good high level, but let me add a couple of nuances. Firstly, our process has no added material and produces no waste products. So unlike a lot of DAC systems where you have an absorbent, for us, the absorbent is the ocean. It already exists. So we are a closed loop process. The only inputs are energy and ocean water. The only outputs are CO2 and decarbonized ocean water. Second thing is that the outflow of our process is benign to the ocean. We grow marine life in the outflow from our pilot plants to show that we are benign. We are wastewater compliant, so things like pH levels, alkalinity, oxygen levels, all the things that people measure for wastewater when you put things into the ocean. We are compliant with those. And our process actually adds nothing into the ocean. All we are doing is taking the CO2 content out, which the atmosphere then puts back because of Henry's law. So the net effect.
What is the actual process once you have pulled the ocean water into your facility? What are you actively doing with it?
So inside the magic box, we pull ocean water in. A small percentage, about 0.5%, is softened. Softening is when you take hard water and you turn it into pure brine, just salt water. Then we feed that into our proprietary technology at Captura, which is called electrodialysis. That's a series of membranes with a coating that is powered by renewable electricity, and it separates molecules, it dissociates molecules and reforms them.
Somewhat of an electrolyzer-like process?
No, electrolysis and electrodialysis are two different things. Electrodialysis uses a different form of membrane and entirely different process and coatings. So salt water, sodium chloride, hydrogen, oxygen. We reform that into hydrochloric acid and sodium hydroxide. The hydrochloric acid is then added to a flow of ocean water as it comes through the plant. It acidifies it to pH 4 within the plant, and that creates a reaction with the dissolved inorganic carbon, and we can then strip the CO2 out using a degassing technology. That gets us our stream of CO2, just like DAC. And then we now have acidic but decarbonized ocean water, but we also made sodium hydroxide, which is an alkali. So we put that in before we put the ocean water back, and that reneutralizes, and out it goes into the ocean where it draws down from the atmosphere. So it's really quite a simple process. It's just using liquids, a liquid to make the acid and the base, and then put the acid in first, pull out the gas, and put the base back in.
Is there any de-acidification benefit to the ocean from this process running? Or are we talking at scales you would have to hit that are so insane that realistically we're not going to get there?
So a couple of things. We remove CO2 from the ocean faster than the atmosphere puts it back. So Henry's law is not instantaneous at scale. As the water comes out of the back of our plant, it has to touch the atmosphere. Think of the ocean water as a constantly moving entity. Every time the ocean water touches the atmosphere, you get the drawdown. But that process of mixing takes longer. So during the mixing period, yes, we are helping to de-acidify the ocean. That effect is especially good in bays, for example, because in a bay you have less interaction between your local water and the wider ocean. And so we decarbonize that bay. I think there's interesting applications, for example, coral reefs, shellfish farming in localized areas where our process can, without changing ocean chemistry, without putting anything into the ocean, where we can help deacidify.
And describe the plant. What's the size of a plant you're both currently building from a pilot perspective, as well as ultimately at scale? Are these co-located with a wastewater facility, for example, or are you building large-scale Captura plants on the coast somewhere or offshore somewhere? How will it physically show up in the world?
So we, broadly speaking, divide our deployment into three categories. The first is using onshore existing infrastructure. So a power station that uses ocean water for cooling is perfect. It pulls water in, it returns it back to the ocean. You put our plant on the back of that, and we can decarbonize that facility as well. So that's number one. Number two is existing offshore infrastructure. So, for example, two of our investors are large tanker companies. On a large maritime vessel, those ones you see coming into ports with lots of container on them, you can put about 1 million tons of carbon removal on an end-of-life vessel. It's basically a floating platform for us. So that's phase two, if you like. And then phase three, we're also actively working on barge-based deployment, where you put our technology on a barge. What I really like about the offshore opportunities is if you can imagine a fixed location offshore, the water is moving underneath. So that gives a push of water through your system, which means that I may not need pumping in that case, or as much pumping. So those are the three phases of deployment as we bring our plants into reality around the world.
And then in addition to the CapEx required to build the plants, from an operating perspective, you're using, I assume, electricity to drive the pumping, as you described, and then drive the electrodialysis. Is that the extent of your ongoing operational requirements?
Yeah, so with having no waste products and no absorbent material, basically our operations costs are some people to operate the plants and then energy. Now, energy is also a significant issue in carbon removal, and Captura's technology has a really big advantage in this area. So, counter to what you may think, the majority of energy use in our system is not pumping, it's the electrodialysis. But electrodialysis is cheap, and remember, we only process 0.5% of the ocean water into acid and base through electrodialysis. So let me give you an example. Let's say we're working with an offshore wind farm. 6 hours a day, the wind is blowing, but everybody's asleep. Nobody wants that energy. So we overbuild our electrodialysis by 4, and in that 6 hours a day, we make 24 hours worth of acid and base. We can then run the rest of the plant all day, but now 70% of our energy use was off-peak or curtailed energy. So this is, again, a very significant factor. CDR faces competition for energy use, for example, data centers, AI. Captura's technology is a really good load balancer. We will power our system and use most of our energy when curtailed energy or off-peak energy is available. Reduces costs, makes us much more flexible.
And from an offtake perspective, is the CO2 that you're capturing out of the separation process, that CO2 is what you're able to measure, report, verify, and sell as an offtake in some way, shape, or form. Then what happens in the ocean is, like you said, sort of a gradual resetting of that from an atmospheric perspective. Is there a discount rate you have to calculate that says, oh, well, we've got this amount of CO2, but in terms of it pulling down from the atmosphere, it's going to take a year or 2 years for that equilibrium to be reached? How do you manage that? Does that question even make sense?
It makes a ton of sense and is a very active conversation. So the first direct ocean capture carbon credit protocol was published by Isometric earlier this year, and they adopt the second of those two approaches that you just described. So we pull the CO2 out of the water, we measure it, we provide it to somebody, or it's sequestered, but the carbon credit is generated when the equilibrium occurs. And you can model that. Those models already exist. We do our own models. So it might take, say, 2 years. And it's usually a curve that rapidly goes up to 80% and then slowly gets to 100.
Are you modeling it locally in the local ocean water there that you see, or the local atmospherics, I guess, is what you'd be modeling?
Seaworthy and Carbon Plan, I think it was, have published an atlas of the world's drawdown characteristics for direct ocean capture. And then we do a localized model on top of that. So that's the way it works today.
Just to be clear, you may deliver a ton of actual CO2 in a canister to somebody, but in terms of their ability to take that as a carbon credit, they may use it, they may utilize it, they may store it, they may sequester it, whatever they may do with it. But to count it, you're actually waiting for the model to calculate what the actual drawdown, and it doesn't matter how much you delivered to them physically.
Correct. And you would show typically 80% drawdown occurs very rapidly. So you get carbon credits for 80% of what you took out pretty rapidly, and then the rest slowly moves up. Now, that's the way it works today. I don't agree with it. Let me try to give you my argument. Henry's Law is a well-known fact. The equalization of CO2 between the ocean and the atmosphere is well understood. Lots of people will tell you about the damage of climate change on the ocean. What really matters here is removing CO2 from the biosphere, which is the combination of atmosphere and the ocean. And if we take CO2 out of the ocean, first, that helps the ocean, which is another victim of climate change. And the drawdown from the atmosphere is an inevitable consequence, as long as you don't position your plant and jettison your water deep into the deep ocean where it never sees the light of day. So if it is a natural and inevitable follow-on and you benefited the ocean, why am I not getting a carbon credit the day I take the CO2 out and sequester it? Ultimately, removal from the biosphere is what matters.
Hey everyone, I'm Yin, a partner at MCJ, here to take a quick minute to tell you about the MCJ Collective membership. Globally, startups are rewriting industries to be cleaner, more profitable, and more secure. And at MCJ, we recognize that a rapidly changing business landscape requires a workforce that can adapt. MCJ Collective is a vetted member network for tech and industry leaders who are building, working for, or advising on solutions that can address the transition of energy and industry. MCJ Collective connects members with one another, with MCJ's portfolio, and our broader network. We do this through a powerful member hub, timely introductions, curated events, and a unique talent matchmaking system and opportunities to learn from peers and podcast guests. We started in 2019 and have grown to thousands of members globally. If you want to learn more, head over to mcj.vc and click the membership tab at the top. Thanks, and enjoy the rest of the show.
The counting of atoms is one of the things that gives DAC, I think, a mental or a psychological advantage relative to so many other carbon removal methods that do require complex models and believing of spreadsheets. With DAC, you can actually count atoms moving through a system. And from a trust and verification perspective, it seems like that is easier to understand than believing someone's spreadsheet. So I hear where you're coming from, which is if you are literally pulling this stuff out through a separation methodology and putting it into a tank and you know exactly how much is in there, it would be easier to sell said amount of CO2 than to have someone believe that over the next 2 years, this scientific process is happening at a certain rate of withdrawal.
And even notwithstanding the scientific process, the benefit of removing CO2 from the atmosphere is crystal clear. You ask any marine scientist, any oceanographer, they'll tell you that's going to help with acidification, ocean temperatures.
Oh, sorry, you said from the atmosphere, you mean from the ocean?
I'm sorry, yes. Removing from the ocean is a crystal clear benefit anyway. So why are we saying the impact of climate change only hurts the atmosphere when we know it also hurts the ocean? So why don't I get credit for taking it out of the ocean straight away? So that's my argument. Doing podcasts like this help broadcast that argument and make it clearer to people, and we'll continue to lobby for that.
How do you, as the CEO of the business, think about how the end product is utilized? Are you a believer that if you're building all this capture technology, the goal is to keep it out of the atmosphere, so thus it should be sequestered? Are you a believer that, hey, as long as it's being used to create some kind of net zero chemical process that is not pulling net new fossil fuels out of the earth, that's okay? I guess the math equation that I'm interested in is how carbon capture companies think about their CO2 being used for something like sustainable aviation fuel or sustainable methanol or the like for tanker ships relative to pure sequestration and the continued use of fossil fuel.
Yeah, it's a great question. I would like to think that I'm an environmental pragmatist. Environmental pragmatist, in my definition, means I care deeply about the environment, but I'm also fundamentally a pragmatist. If you take a step back, we have to build a carbon removal sector at massive scale in the next 25 years. That's going to be really, really hard. I can't emphasize how hard that's going to be. So the pragmatist in me tells me whatever moves the dial, whatever moves the ball is a good thing. And if that accelerates the deployment of the technologies, the development, the bringing down the cost curve, bringing brilliant, innovative people into the sector to get us to the end game where we're removing massive amounts of CO2 from the atmosphere, that's a good thing. So our approach is very similar to the one that I used at Carbon Engineering, which is we will license our technology to partners. They can sequester, they can produce CO2, they can make aviation fuel or whichever mechanism they want. All of those things are driving our company forward and bringing this technology into reality at massive scale. So that's just a good thing.
One of the things, presumably with your solution that is less likely to be a utilization pathway is enhanced oil recovery, which I know for Oxy and 1.5 and Carbon Engineering has turned into one of the main things they're using that CO2 capture for. And I would say in climate circles, that's a quite controversial thing to say we're going to do direct air capture in order to drill for oil, net new exploration, but one that is in theory carbon negative because we are sequestering the CO2 we capture deep underground as part of exploration. I'm curious how you have thought about that and if that's something you don't have to think about at all now that you're building Captura.
So firstly, I have a fairly significant past role in that path of events, having negotiated most of the agreements that Oxy and Carbon Engineering did. Again, I look at this pragmatically. If it wasn't for the potential for Carbon Engineering's technology to be used for EOR, would Oxy have built Stratos? And by building Stratos, carbon dioxide removal at scale is about to see demonstrated for the first time at 500 kiloton scale. That's a big step forward. Now, I don't know, I haven't followed it recently, but an awful lot of the capacity of Stratos is not going to EOR. It's going to pure sequestration for the production of carbon credits. You can see the announcements that 1.5 have made over the last 2 to 3 years in offtake. That's for sequestration. It's not for EOR. So I think the EOR business plan is for sure part of the reason why Occidental was interested. But the end result is we have seen a direct air capture technology get to scale for the first time with Stratos. So again, the pragmatist in me says, we've moved the ball down the road. We've proven this technology at scale now. Now, does the world now want to start getting serious about environmental regulation and net zero and building a market for pure CDR? Because if the world does that, now we've proven the technology at scale. It's got to be a good thing. You're right, for Captura, much less of an issue, if you want to term it an issue, because, of course, we have to be ocean-based and the majority of EOR applications are inland.
What are the current primary pathways for Captura?
Very much sequestration and synthetic fuel production, as you would anticipate. Basically, we're exactly the same as a DAC company. And so the same end markets, the same opportunities. Regrettably, today, we may not get into 45Q. The wording of 45Q says you have to remove CO2 directly from the atmosphere. I'm spending an awful lot of time lobbying for the addition of 2 letters, IN. So indirectly from the atmosphere also qualifies. So we don't qualify. We're making our argument as to why we should. So unfortunately, we don't get access to those programs.
What's the other side of the table saying in that argument? Why is it only direct capture that qualifies today?
That's just the way the legislation was written. And at the time, for example, direct ocean capture didn't exist. So the legislation was written pretty technology specific. I think part of the motivation at the time was they wanted to support those forms of CDR that, like you said earlier on, produce a concrete, measurable amount of CO2, rather than, for example, enhanced rock weathering or ocean alkalinity enhancement, where you don't have that. So they wrote it in a way that was very specific, and it makes it maybe challenging for us to qualify. We're obviously trying.
On that latter subject, one of the things we haven't talked about is some of the other ocean-based methodologies for carbon capture. We've had some guests on the show before that have done things like ocean alkalinity enhancements or enhanced rock weathering. And those are back to those same, you have to believe the spreadsheet, you have to believe the model type of pathways. You're not, at least currently, directly counting the atoms that are flowing through either one of those pathways. Is that correct?
I think that's a fair comment. I mean, focusing mostly on the marine CDR world, ocean alkalinity enhancement involves putting material into the ocean to increase its alkalinity, which results in more drawdown into the ocean. There's a couple of things about that probably challenge the CEOs of those companies. One is that you're adding stuff into the ocean. The moment you do that, you're subject to the London Protocol on ocean dumping. You're subject to the danger of people seeing that is a threat to the ocean. And then the second thing, of course, is you need input material. And any solution that's trying to get to 10 billion tons a year, which is what we need of CDR, if you need 10 billion tons of input material, that's going to be a challenge.
Moving rock around the planet is heavy and hard and expensive.
Precisely, yeah. And crushing it and doing all those things and putting it into the ocean at that scale. So Captura's solution aims to avoid both of those two things. Firstly, we're a closed loop system, no input material, no waste products. And secondly, we add no material into the ocean. So we think we're a more sustainable solution. I've always been an advocate for every stream of CDR. We need as many. That's the environmental part of my environmental pragmatist. We need as many solutions as possible. So I'm not suggesting that OAE doesn't have a role. It's a different approach and has different barriers.
What inspiration do you take today from other industries that you view as a potential model for how Captura can grow and expand?
That's a great question. I would like to see that the CDR industry is able to follow a very similar trajectory to the renewable energy industry. And let me explain why I say that. The initial phase of that industry was technology proving. Is this going to work? And there was government funding available for that. There was some brilliant ideas. Some companies had great ideas and succeeded. Other ones didn't. Then you get into first deployments. And first deployment's always tough. Adoption is always tough. It's the single hardest thing about being a startup is getting to commercial deployment. And that's where government subsidies, tax credits, whatever it may be, different countries had different approaches, helped get over the hump of early adoption. And now we see, of course, that renewable energy prices are falling and quite competitive. I hope that governments will stay away from interfering with the industry. But I think if that was the case, you would see renewable energy prices continuing to fall. So as I look at carbon dioxide removal, I see it as a similar infrastructure industry. We're in the technology proving phase. Some companies will succeed, some companies won't. Help from government is awesome when you're in that stage. difficult to get funding when you're just a piece of paper and an idea. Then we move into first deployments, which are tough. CDR will be more expensive in the early days for sure. That's where we need government programs to assist in that, or early adopters like a Microsoft and Frontier and others. Then you move into the steady state. And the steady state is where the technology is proven, the market is understood, project financing is easily available, and you deploy as quickly as you can.
With the renewable industry, ultimately, you're trying to get to a point where you're cost competitive or better than existing legacy sources of power. With CDR, you're building an entirely new thing. From an adoption perspective, I'm trying to get my head around what causes big companies to ultimately feel forced to adopt. We don't have a compliance market in the US, for example, or a significant one. How do you see that adoption driver evolving?
Look, it's the single biggest need. If we had a regulatory environment in any country, I won't pick on the US or anywhere else in particular. If we had a regulatory environment that says you have to reduce your carbon footprint to be selling in our country and you have to get to net zero by year X, then you would see a flourishing industry. Now, why do you not have that today? I think because you don't have public support and you also don't have the technologies proven. So we, the industry, have to work on both of those two things. So proving the technologies is showing that they can be at scale, as I talked about earlier on. And then getting the public support is by, in my opinion, not threatening the public. If you go to the public and say, you can't fly anymore and you can't eat beef and you can't do this, that, and the other, you've got to drive an electric car, I think people react negatively to that. What I like about CDR, what I've always liked about CDR is it allows for continued use of fossil fuel in difficult sectors with their resulting emissions removed and permanently put underground again. And that way you get to net zero without impacting those sectors that have no alternative right now except to use fossil fuel. Maybe in 50 years, somebody will invent an electric plane, but we don't have it today. If you don't have it, then decarbonizing by CDR works. And that way is less threatening to the public.
What governments today are doing the best job here, in your opinion?
I was talking to some people the other day. I live in Vancouver, British Columbia, and they said the best climate policy in the world is in British Columbia. And that made me think a little bit. We have a low carbon fuel standard here, which treats a CDR credit equivalent to the carbon intensity reduction in a synthetic fuel. In other words, they are embodying exactly what I just said. If you can't stop the emission, remove it and put it permanently back underground again. And unfortunately, BC is a small market. So that small regulatory market like that doesn't create a global industry in CDR. But that type of regulation where you don't specify the process, but you specify the outcome as government, I think will allow the innovators. And if you're the CEO of a large airline and you have to do this to continue operating, you're going to go find the best solutions. And that's the way industry has always worked. I think that creates innovation that way.
So far, it feels to me like the early adopters of this technology, you mentioned the Frontier and Microsoft, which Microsoft obviously is the 800-pound gorilla in this space. From a commercial perspective, in addition to Microsoft, it's been the airlines, the shipping companies, and then I would say from a heavy industry perspective, really Oxy from an oil and gas perspective. But you haven't seen a lot of heavy industry adoption outside of transport. Why not? These are some of the most emittive companies on the planet. Cement, steel, chemicals. Why are we not seeing those types of businesses start to adopt purchasing carbon removal?
I think there's a couple of reasons. This is just my own personal opinion. It's a good question. I think the fact that we don't yet have cost-effective CDR at scale for industries that don't have heavy margins. The technology industry has good margins. You and I buy lots of iPhones or operating systems and so on, and they make good margins.
Lots of advertisements pointed at us too.
There you go. Yeah. So that's good. So you have the margin to be able to afford. But I think the second thing is that the types of companies that are early adopters and leaders are often the ones that are directly customer facing. Whereas if you're a steel maker or heavy industry making chemicals or something similar, you're a step away from the customer at least. So your role in not being carbon neutral is less visible to the customer.
Even though your product is incredibly carbon intensive, you're someone else's scope 3.
Correct.
Who is the actual consumer-facing brand.
So your imperative to fix because of social or public pressure is less. Combined with lower margins in your business, those businesses tend to be large volume, low margin. It's natural, which again goes back to what I said earlier on. It's on us, the carbon dioxide removal industry, to prove that we can be at large scale and cost effective. And that was a large part of what drew me to Captura, because its use of the ocean makes that extraction process easier. No chemicals, no absorbents needed. That really cool trick with renewable energy, being able to use off-peak energy to lower costs, I think really position technologies like ours to be low cost and scalable.
And where are you today in terms of deployment, proving the concept out? Can someone go tour a Captura plant today anywhere in the world?
I'm going to say yes to that. And I'll tell you why I can say yes to that. If you go to our website, you can find a virtual tour of our pilot plant in Hawaii. So the first pilot system is operating in Kona, Hawaii. It's just by the airport for anybody who's been to Kona before.
Steve, that is not a terrible place for you to have your first facility to have to go visit all the time.
It's tough for our team having to go out there all the time. I always say to investors or partners, one of the reasons to work with Captura is you can justify a business trip to Kona. So it's a nice thing for them. So we built that plant from scratch, from bare earth in 70 days, fully commissioned. It worked first time. So all of the KPIs were met the very first time, the key performance indicators. And it's been operating now for 6-7 months, hundreds of hours of operation, all exactly on performance. So we're now moving into commercial deployment. But to allow people who can't get to Hawaii to look around the plant on our website, a full virtual tour. It's like when you buy a house and the realtors put up a little tour where you can walk into each room and then you can press a button and it will tell you what each piece of equipment is doing and how it contributes to the process. So people should take a look. It's kind of a fun thing.
And is the Hawaii facility a pilot prove the technology facility, or are you producing offtake out of that plant today?
It's overwhelmingly for us a pilot and technology proving facility, but we do provide some CO2 to the aquaculture industry on Hawaii and also the dry ice community. And we're looking at some of the food and beverage customers in Hawaii as well to provide CO2 to them.
And what will be next for you in terms of getting to commercial scale?
So a couple of things. Interestingly, for a CDR company, the electrodialysis and the membranes that we produce are independently an interesting market. So, for example, they're used in lithium mining, they're used in long-term energy storage, desalination. So we envisage a market that we can have selling those products into market. And then for Captura's direct ocean capture business, we're all about the first plant. We now want to move into commercial deployment. We've proven our tech. We've got a facility in Pasadena, California to build out our systems. We're all ready to go. So we're talking to the offtake market to get sufficient offtake commitments to allow us to project finance the first plant.
The first facility is in LA somewhere?
No, I think the first facility we build is likely to be in Europe. We're looking at a few locations right now, but I think Europe is winning the race.
And does that have to do with the regulatory environment there from a climate perspective?
It's a combination of things. We have European investors who are interested in working with us on bringing that technology into Europe. There are good locations onshore with existing water flow that we can use. Sequestration is up and running, like the Northern Lights project in Europe. So there's a few good reasons to put it there. It's less the regulatory environment or the political climate right now. It's more that the best features for a first plant all are there in Europe.
And what can you share about how you've capitalized the company to date?
I think we've announced that we've raised about $47 million to date, which is great. We have some really good investors. I've always held the view that to build out CDR at the massive scale required, companies like ours need help and assistance from big brother companies. So we have some terrific big brother companies on board: Equinor and Maersk, Aramco, MOL, Hitachi, 3 renewable energy companies in Europe. And they're actively helping us with deployment and looking at availability of locations and so on. So that's been terrific. We're now doing our Series B, which we hope to close before the end of the year. And that Series B would take the company either to or very close to profitability. And then we'll be in a position to deploy, hopefully rapidly, in the partnership model with licensing. We can build plenty of plants in parallel around the world and answer that question about whether CDR can be done at large scale and at a reasonable cost.
Well, Steve, I don't know that anyone has taken one carbon removal company from pilot to an outcome, and you've done that, and you're trying to do it now with your second. What are you hoping to be able to look back from a legacy perspective and reflect on at some point in the future?
It's a good question. I find the ingredients that make startups successful really fascinating. What I found, for example, when I joined Captura was academic founders who knew everything about the technology and recognized that they needed a business person. I'm a business person. If you ask me the electrochemical process inside our electrodialysis, can't help you. So for me, the greatest reward and the greatest interest comes from forming a team that collectively covers each other's weaknesses to achieve a big win. And I don't mean a big win financially. I mean a big win in terms of getting something to market and deployed. So for me, I remain a very strong believer in direct air capture. I think the hub model that the Occidental people are doing is absolutely the right model. Find a location with lots of renewable energy and sequestration and build as much direct air capture you can in that location and offer carbon credits around the world. I think that's a very sensible model. But we need a lot of it. The ocean is really big. The inherent cost advantages of using it, I think, are really clear. So bringing an ocean solution and a air solution to the table, I think I'd be pretty happy with that. And if that means that we get wider adoption of CDR, recognition by the public and the politicians that this technology is ready and we can start writing the regulations that we need for net zero, I'd be quite happy to have that. That's a lot to be carved onto my headstone, but something like that.
Well, Steve, thanks so much for taking the time to share with us today and share with me what you're building. I learned a ton, and I'm excited to continue to watch the journey with Captura and your leadership in the carbon removal space.
Thank you very much for your interest. It's shows like this that help build the public interest and support, so I really appreciate your time.
Inevitable is an MCJ podcast. At MCJ, we back founders driving the transition of energy and industry and solving the inevitable impacts of climate change. If you'd like to learn more about MCJ, visit us at mcj.vc and subscribe to our weekly newsletter at newsletter.mcj.vc. Thanks, and see you next episode.